Hello once again, everyone. My name is Malcolm Miller. I attend North Carolina Agricultural and Technical State University, and I'm here to talk to you today about shift registers. In section 2 of chapter 8 in our book, we learned about shift registers. If you don't know what a register is, you can think of it as a device used to store data. Now, data is only stored into the register if certain conditions are met. It's usually when a low input is asserted, which means turned on, and is the rising edge of the clock. And a register can also be reset to all zeros by asserting a reset input. I know I just threw a lot at you. I'm going to try to explain it as best I can. Now, the clock I'm referring to is not the same clock that you use to tell time. The clock that is referred to in an electronic device can be thought of as like a digital metronome. Every tick of the metronome can be thought of as a 0 or a 1. The clock is used to keep the actions of the circuit, quote unquote, on beat, and that beat is usually either the rising edge when the clock goes from 0 to 1, or the falling edge when it goes from 1 to 0. And I said data is only stored into the register when a load is asserted. And you could think of the load input kind of like a battery. Your remote has batteries in it, but if the batteries aren't good or there aren't any batteries in the remote, it doesn't matter what you press, the TV is not going to get that signal. So the load similarly tells the register, okay, we can store whatever the input is into the register. It does, without the load being off, the data will not be stored. Now, the purpose of a shift register is to move the contents of the register around. You can shift either to the left or you can shift to the right. With shifting, each value is taken and moved one place over in the direction of the shift. So let's say you have a number, 3 input number, say 100. If you shift that to the right, you will get 010. And that's assuming your serial in bit is a 0. And the serial in bit is used to take the place of whatever value is being shifted out. Because the shift can't keep the whole number. You just move everything over one spot. And to have something in the one spot that was left out, that's where your serial in bit comes into play. Now, like the load, the shift action is only performed when a shift input is asserted. And this only takes place at the rising or falling edge of the clock as well. So to be able to shift, you need to, one, have a clock going on in the circuit that tells when it's a rising edge or a falling edge. You will need a reset, which will reset the register, whenever you want it to be reset. And you need a load input, which tells the register if something can be loaded into it or not. And you need a shift input, which tells the register if it can be shifted or not. Then you also need the value that you want to store into the register, which can plainly be called an input. And you need a serial in bit to take the place of whatever value you're shifting out of the register. And then you need an output to display everything that you just done. Signing off, everybody.